So we're going to find slope and x and y intercepts when given either a linear equation, a function table, or a graph. So let's start with a basic linear equation in the form of slope-intercept form. So y equals negative 2/3 x plus 3. So we know from our notes that slope-intercept form looks like this. Y equals mx plus b, where m is your slope, so the number in front of the x is your slope, your rise over run, and b is your y-intercept, where the line crosses the y-axis. So the first thing we can identify then is right here, positive 3 is our y-intercept. With that, we can place a point on a graph at 3 on the y-axis. Okay, we know this right here is our slope. So slope is m. So that means it's up 2 and over to the left 3. Now, to find our x-intercept, we know that any point on the x-axis has 0 for the y-coordinate. So all we have to do to find the x-intercept when we have an equation is substitute 0 for that y. So 0 equals negative 2/3 x plus 3. Okay, I got to get the x's by themselves, so I'm going to do the opposite of the number, so that's negative 3. So I'm left with negative 3 equals negative 2/3 x. We know from previous work that a fraction in front of a variable can be canceled by multiplying by the reciprocal. So 3 on top, 3 on the bottom cancel, 2 on the top, 2 on the bottom cancel. Negative times negative is a positive. Then we do the same thing on this side. So multiply by the reciprocal when you have a fraction in front of a variable. Okay, we've been learning again or reviewing how to compute fractions. So I'm multiplying, so negative times negative is a positive. So I have x equals positive 3 times 3 on top, 2 times 1 on the bottom. So 9/2, or change it to a mixed number, 4.5. So I can find the x-intercept, the y-intercept, and the slope using an equation in the form of slope-intercept. So now let's do a different type of function. Let's take a function table. So we'll do our function table with just a simple t-table. So this is our x input, this is our y output. So we have to remember the vocabulary. Input is also our domain. Output is our range. So given our x input 0, 1, and 2, okay, I'm going to say that this is going to be negative 2, 0, 2. So now I'm giving you the function. You have to tell me the y-intercept, the slope, and the x-intercept. Well, we know that when x is 0, right there, that y is our y-intercept. Okay, every place on the y-axis has the x-coordinate of 0. So that's why we specifically use this input of 0. So we know that the y-intercept is negative 2. Now in this particular problem, we actually have 0 for one of our y-coordinates. So just like I mentioned back here, when y is 0, we're given our x-intercept. So it just so happens that this particular function has that right there. So when y is 0, we're given our x-intercept. That one is an easy one. Now, how do we find slope? We know slope is the rate of change of the points. It also is our pattern of y's. It's our rise over run. So if we have these counting by ones, all right, then this is our pattern over here. So I'm going from negative 2 to 0, and 0 to 2, so that means I'm adding 2 each time. That is our slope. The rate of change, the pattern, is the pattern of our y's. So slope is 2. Now what that allows us to do is actually write an equation for this in the form of slope-intercept. Y equals mx plus b. So we know the slope is 2, so we replace the m with the 2. And we know the y-intercept is negative 2. So from our function, we're able to find those 3 answers, plus we're able to write this function in slope-intercept form. Okay, next one, we're going to have a graph. So let's make this graph about like this. About like that. Now we also have to be able to find again the y-intercept, the slope, and the x-intercept using a graph. So the first thing, we can see that it crosses the y-axis at -1. So there's our y-intercept. Now to find slope on a graph, we use slope triangle. So I need to find some different points that I can identify. So there's one. And it looks like, let me see. Here's one. And maybe, I think this is right there as well. Okay? So there's 3 points. So now we can use our slope triangle. That's our rise over run. So I'm going from here up and over, up and over. And you can see it makes 2 slope triangles. So when you have a graph, to find the slope, you use slope triangle, which of course still is rise over run. So in this case, our rise was 2. And our run was 1, 2, 3, 4, 5, 6 in the positive direction. So that's 2 over 6, and then of course we have to simplify, or 1 over 3. And this would have done the same thing, up 2 and over 6, so make sure they match. Now, we could have also picked these points right here. So if that were the case, notice that our slope triangles would have been a little bit smaller. It would have been up 1 and over 3, up 1 and over 3. So it doesn't matter which slope triangle you use. These are all similar triangles. We want to actually try to make the smaller slope triangle because then we don't have to simplify. So our slope was 1/3. Now, to find the x-intercept, where we cross the x-axis. So in this case, it actually shows us right there at 1, 2, positive 3. Now, if we had a line that crossed at a place that we didn't know, we would have to write our function as an equation, and then, remember, substitute 0 in for the y. So let's go ahead and do this. Let's write an equation for this in the form of slope-intercept. Y equals mx plus b. So we know our slope is 1/3, and we know our y-intercept was -1. Now let's just double check that our x-intercept is correct. Remember, we substitute 0 in for the y, and we solve for x. Okay, I got to get the number over the other side, so add 1 to each side. They cancel. 1 equals 1/3 x. Remember earlier in the video, to get rid of a fraction in front of a variable, and multiply by the reciprocal on both sides. So they cancel. So I'm left with x equals 3 times 1 on the top, 1 times 1 on the bottom. X equals 3. And of course, we already knew that, didn't we, from the graph. So what I just did is started in the first problem with an equation, and I found the y-intercept, the slope, and the x-intercept. Okay, I started with a function table, and I found the y-intercept, the slope, and the x-intercept. And then I started with the graph of a line, and I found the y-intercept, the slope, and the x-intercept. So what we'll do tomorrow and Thursday is we will also add a couple other types of functions, a pattern, tile arrangements, and we're going to be able to go back and forth between them. So these are the basics, so good work.